Hello and welcome back. In this chapter, we will begin delving into chapter 17. The subject of chapter 17 is sound. So recall from chapter 16 that sound is a wave. We studied waves in chapter 16, and as such, it requires an external medium to transport energy from one point to another. Recall that the only type of waves that can propagate from one point to another without an external medium are the electromagnetic waves. Also recall from chapter 16 that the speed of a wave is given as the product of its wavelength and its frequency. And because the frequency can be re-expressed as 1 on the period, we can also find the wave speed by taking the wavelength and dividing it by the period of the wave. The speed of sound is different for different materials. In general, the more dense the medium, the faster the wave travels. So some of you maybe have seen these old westerns on TV or on Netflix or something like this, and somebody wants to find out if there is a train traveling on the tracks that's going to be reaching their point relatively soon. And so instead of listening in the air, they'll put their ear to the steel rail. And that's because the sound wave will travel faster in the steel than it will if they just listened in air. So they'll get a heads up earlier if they have their ear to the steel and hear that sound wave than if they wait to hear it in air. In air, the speed of sound is a function of temperature. So it's 331 meters per second times the square root of the temperature of the air divided by 273 Kelvin. Notice that you can see that the temperature you plug in here must be in units of Kelvin so that you can have a cancellation under the radical and remain with units of meters per second, which is, of course, what we want for speed. This formula is valid for all frequencies and wavelengths of sound. Also recall from chapter 16 that we introduced intensity. Intensity is power per unit area. The threshold for human hearing as far as intensity of a wave goes is 10 to the minus 12 watts per meter squared. That is the smallest intensity that is still detectable by our human ears. We're going to give that a special symbol, naught. So this is I sub naught is going to keep track of 10 to the minus 12 watts per meter squared. We as a society in general employ what's called the decibel system, dB system, to express the relative intensity of the sound wave relative to the threshold of hearing, 10 to the minus 12 watts per meter squared. The formula that gives you the relative intensity in decibels, using the symbol beta for the number that you actually get for that measure on the decibel system, is 10 times the log base 10 of the intensity you're calculating on the decibel scale divided by the threshold of hearing for the human ear. So for an example, if the intensity of sound at a concert, for example, is 10 to the minus 4 watts per meter squared, then on the decibel scale, we would use the formula 10 times the log base 10 time of the quantity 10 to the minus 4 watts per meter squared, the intensity at the concert, divided by the threshold of hearing, 10 to the minus 12 watts per meter squared. In the parentheses here, we're going to have 10 to the 8th. When we take log base 10 of 10 to the 8th, we get 8. 8 times 10 gives us 80. So the concert then, we would be able to relay as a loudness to one another as an 80 decibel level concert. So this gives us a step into chapter 17, and then the next couple of videos we'll finish covering the rest of the topics related to the subject of sound. So we'll see you next time. Thank you.